All right, now we're going to graph a brand new type of sine function now, because this one, I mean, you can look at it and tell the difference. Before, they were kind of just of the form, y equals something. You could have maybe an amplitude here, sine, and then it was just, say, 3 theta, or 3x I was putting down. We were replacing the x with theta because they're pretty much going to be the same thing here. But now we're adding and subtracting stuff within a parenthesis right there. So our frequency, which is still right there in front of that theta symbol, which is k. Now before, we called k b. So we're changing this up a little bit. But the frequency is still the thing right before theta. So what I'm going to do is get my green ink here going, and I'm going to write amplitude, frequency, period, and the phase shift will be our new thing that we're going to have to find here. All right, starting at the top, the amplitude is a 1, okay, because that's right there. That's 1. That's 1 sine theta. So amplitude is 1. Remember, that's absolute value. The frequency is going to also be 1. How very boring. But it's going to be the number right in front of that, and it's a 1. If it was 2 theta minus pi over 2, that would be a different kind of problem, and we'll do those later. But the frequency is 1. The period is, of course, just equal to 2 pi divided by the frequency, which is 2 pi over 1, which is 2 pi. So that's the period of this. Amplitude and frequency. This is a fairly standard thing, just with a phase shift in it. Now, here is how you figure out a phase shift. You take this right here, right there. If it's minus something, it's going to shift it. Well, the phase shift will be positive. If it's plus something, the phase shift will be negative. So the signs are, in fact, backwards. All right. So if you're taking away this, it's going to shift it in the other direction. So it's going to be positive. But there's more to it than that. So what you do is you take the phase shift, which is pi over 2, and since it's minus pi over 2, I'm going to call it plus pi over 2. Let's make a note here in like red to change the sign. That's sing. The sign. GN. Change the sign of this thing right here. So that's the sign that we're talking about. Okay. So I'm going to make this a positive, and then I have to divide this by the frequency. Okay, which is k in this thing. And the frequency is 1, so it's just pi over 2 divided by 1, which is, of course, pi over 2. Now, sometimes if the frequency was different, like if it was 2 pi, then it would be pi over 2 divided by 2, and you would have to do a little bit of math there. But we have our phase shift here of pi over 2, and it's positive. Okay, positive. That is something that you're going to get better at the more you do, but now let me show you how to graph all this. So we're going to make a nice elongated graph like so, way out through there. Okay, make a big one. And on this graph, I'm going to grid this thing off strategically, all right, because I know the amplitude is 1, so that's usually what I slap on here first. So that's a 1, and this is a negative 1, and this thing isn't going to be shifted up or down. This is actually plus 0 right there, so it's not going to be shifted up or down. So it's going to lie right here. The midline is going to be the this axis right here, this radian, this theta radian axis. Otherwise, we call it the x-axis, but it's going to be that right there. And we'll go ahead and what I'm going to do here in yellow is graph a standard sine function that obeys these 3 things. So I'm going to have a period of 2 pi, and that's what we've been doing all quarter here, or all year so far. So that's going to be pi over 2 pi, 3 pi over 2, just like you're used to doing, and 2 pi. And this thing is going to make it. It's a sine function, So it's going to make one wavelength out to 2 pi. So I'm going to do the best I can here with that. It's going to come up and come down here. Not the greatest thing in the world. Down and then back up. Okay? Not super thrilled with that. Let's try that one more time. So up, down through here, and then back up. There it is. Very nice. What's different about this, and I'm going to graph the phase shift, or the actual graph here in red. This is going to be shifted pi over 2. So this thing is going to be shifted forwards on this axis in this direction, pi over 2 units. So now what I've seen a lot of people do, and I'm going to do it too, is I'm going to make a dotted line right down through here. This is how I was taught to do this. And that's going to basically be my new y-axis. Okay, so that's where this thing is going to start. And my intervals are going to basically be the same, except I'm going to have another one over here to complete its wavelength, its period, because it's going to be 2 pi. But it's instead of starting at 0 here, it's going to start at pi over 2 and go like this. So it's going to go up here, down, down here, and then back up to this point, which that point right there is just 2 pi plus pi over 2, which is, 5 pi over 2. 5 pi over 2. That would be what that is right there, 5 pi over 2. So this is a great example of phase shifting. So the actual graph isn't the yellow one. The one you would want to put on your paper is the red one. But when you go shifting this thing left and right, and tomorrow we'll do it up and down, you have to basically do 3 different graphs to get the one you want. It's very challenging. And I will just say that this is my intro problem. Like the amplitude was one, the frequency was one. That was very kind of me to do that. But the only thing that I was different about this is this whole notion of phase shifting. So let's review that real fast. You change the sign. So this was minus pi over 2. So when you do the math here, make it positive pi over 2. If this was a plus sign, this would be minus. One more time. If this was a plus sign here, this would be minus pi over 2 right here. And of course you're dividing it by the frequency, which is the number in front of the theta, which is 1. All right, and that's a phase shift. If it was a negative phase shift, it would start over here and go at the same route with the same period. All right, but more on that tomorrow. See ya.